Okay, so it's time for the second presentation, and the presentation will be held by Simon Schäfer, who is actually coming from University in Karlsruhe originally. He's working with us at Virtus Lab, and he's one of the most active contributors for the Scala IDE and other open source projects as well in the Scala ecosystem. So please welcome Simon, and Simon will share some thoughts about general tooling platform. Simon, thank you.
All right, thanks, Rafael. Okay, as Rafael just said, I'm an IDE developer, and as such, I care a lot about tooling support, and I think a lot about how to do tools correctly, and not just about how to do IDEs correctly, but also about how to do documentation tools correctly, and build tools, and all these kind of things. And actually, this is one of the reasons why I actually started to contribute to Scala IDE in the first place, because at the time when I started, nothing worked. It was a time where this compiler crashed every few minutes, something like that, when you used it, and where the IDE didn't work at all. At least it doesn't crash every few minutes anymore. Yeah, and doesn't work. Okay. Yeah, we can wait a few minutes. I don't need slide at the beginning. Anyway, one of the things is that over all the years where I contributed to Scala IDE, I never got really happy with our tooling support. It's just, it somehow works, but I don't get excited about it. It just is not really, really good. And at one point I sat down and I started to think about what exactly are the reasons why tooling is not that great. I mean, most people, they have their pet peeves about tooling. They all know things which don't work the way how they should work, and it's very annoying. And the usual things to do is to just say, okay, that this is just because we don't have enough people working on tooling and so on. And I just said, okay, but this is not really this is probably not the origin. I want to really go to the foundation of why are our tools broken. And this is exactly what drove me to Scala in the first place, because Martin once said that he wanted to fix a programming language in its origins, in its roots, and he just didn't want to fight symptoms, but really fix where problems actually are created. And so, and this talk is also about more or less the same idea. How is it possible to develop tools in a way that maybe is completely different to what we do today, but which would lead to a completely different design to tools, and which would lead to just better tools. All right, this is the point where I actually would go to next slide, but it will not work. Okay, I just can't continue talking. So I don't know if in the end I'm going to come up with anything extremely useful, or if it's just nonsense, but we will see how it works out. Yay. All right. Now, one of the very first things which I discovered is what I would like to describe as the tooling cycle. It's something which which no one is really aware of. We just take it as granted that this tooling cycle exists, but we don't really think about it if it's really what we want. So, as an example, nowadays we have a tooling landscape, and it's actually, to most people, it's very clear. We have editors, IDEs, documentation tools, build tools, and a lot of other stuff. And that's more or less the same for all programming languages. There's no change between, or no big change between different programming languages. And if you look why this is the same, there's actually some kind of cycle in there. So for example, if a new programming language is created, someone just first starts to think about it. The second thing is, once they thought about it, they write a compiler, because they have to check out if it works. And once the compiler is written, usually they have to integrate it into some editor, because yeah, it's just to get the syntax highlighting, for example, and these kind of things. And after that, if the programming language turns out to be successful, people start to create IDEs and more powerful tools like BillTo, and that's just how it happens over time. And this is actually the point, which is true for all programming languages, that someone somehow finds out that we are all doing it wrong and a new programming language shall be created. And at this point, the cycle starts again, because a new programming language is created, and yeah, we are back at the first point. Okay, I just said this. And driven by all the enthusiasm about what we could do make better, we just follow this path without ever thinking about it if it's really necessary. Because if we go back to the first point, it means that we have to more or less throw away all of our knowledge about what the tools we have already and just do everything from scratch once again. And yeah, my question here was, what if this is all wrong? What if there's a different way how to develop tools? Yeah, exactly. So in the end, we just don't know what would happen if we would try to break out of the cycle, if we would arrive at something better, or if it just would fall into chaos and wouldn't work out at all. All right, but if you look at this, this is not the only assumptions people make about tools. One very lovely example, which I like a lot, is the fight about editors and IDEs. And I like it a lot because it's actually completely pathetic. So there is this general belief somehow that IDEs are slow and heavy, but very powerful. On the other side, there are editors, they're fast and lightweight, but they are completely useless for big projects where you have lots of dependencies, lots of people working on the projects, and lots of lines of code changes every day. And okay, go one slide back. But if you look at this, there actually doesn't exist a definition which says that an IDE is slow, heavy, but powerful. It's what people think of. It's not that this is what an IDE is. And in fact, this is completely true and completely false. I believe that the cycle over all the time, that it led to exactly these beliefs, and it led to what we have today. A lot of poisonous assumptions which more or less drive us away from fixing real problems, but just always fighting against symptoms. Now, in the following, I want to really question if this cycle is really necessary and the only way how we can develop tools, and if we can break out of it and see if we could arrive at something better. Okay, and what I would like end up with is a complete new model for a tool which just doesn't exist today. Now, there are actually three main goals which I identified about what we need to do to actually get to such a tool. Get me to the first main goal. So the first one is a so-called unified interface. What I understand with this is that in the end, we only really want to have one single tool. We don't want to have a compiler, we don't want to have an IDE or documentation tools or command line tools. It's just not necessary. What we really care about as developers is we want a way to do our job and to access the tools. And we don't want to care about if it's now the compiler which solves our problem or if it's the IDE. It just doesn't matter. Now, for dev area, of course, we still want to have a complete split here, because if we would pack everything into one big project, it would just result into chaos for sure. But for users, it's just what we want to do. And the question is, would it be even possible? So in this picture, I showed how this could look like. For example, we have at the top here, we have what we know nowadays as tools. We have, oh no, it's here at the bottom. The compiler, for example, the IDE, the BillTo, this is all what we know today, and this is all what we have to use as users today. What I'm proposing is that we need one single interface, which is this tooling platform, and it just allows us to access all tools at once. And on top of this tooling platform, what we could do is we could just add different interfaces to access the information which the tools provide us in different ways. We could have editors, command lines, browsers, IDE frontends. It would more or less work in the same way how it would work today, but with the enormous difference that it would just be one single tool. Okay, if we scroll to the right here, we can see that at the top is the presentation layer and at the bottom the backend layer, and they are somehow connected through a protocol, which I will come later to it about the point of that one. Okay, in the end, what this really forces us to do is to rethink what a tool actually is. Now, the second main goal is a so-called component-oriented architecture. This is something which most people believe that we have it already, but we don't really have it, because the idea here is that we not only want to have a modular platform which is split up between components, but that all of these components that they're composable. And if you look at nowadays IDEs, while they're very big and split up into reusable, or at least some kind of smaller modules, there's no way that we compose them and build them together to something bigger. And one thing, for example, what we could do with composable components is we could create a query language which would allow us to just abstract from the technical details of the communication between these modules. It's something which is really, really difficult to do today because, for example, if you imagine two classes and you want to communicate between two classes, you somehow have to pass a reference to the class, and while this works, it has the problem that one class needs to know another class, and I'm going to remove that one. And for example, if we look at an actor framework, what we have here is we have different actors, but they don't know each other anymore necessarily. They more or less communicate through messages, and if we just drive this a little bit farther, it would be interesting to find out if we would completely remove any dependencies between components and just make them in such a way that we can compose them without knowing what we compose in beforehand. Because in the end, composable components and a query language would lead to automation. A very famous example of this is Vim, the Vim text editor, because in Vim, if you look at it, there are so-called comments, and for example, if you want to remove a line, or if you want to jump to a next word, or if you want to change a word, it's all just a comment in Vim. And all of these things, they can compose together. So for example, you can say jump to the third word, and these would just 2 different or 3 different comments. It would be a jump comment, it would be a word comment, and it would be a number comment. And all of these things, they can compose together. And when we compose them together, what we have is programs. You can just execute these programs several times, and yeah. Well, yeah, as an example, one of my personal pet peeves about Scala are linting tools, because we have a lot of linting tools in Scala. So for example, there is the Xlink argument for the Scala compiler, there's Scala style word remover, abide, scapegoat, and a lot of other stuff. And actually what they're doing, they're more or less doing all of the same, but they're still kind of different, and therefore they're different projects. And the question here is why they're different projects. In fact, what we need here is we need even comparison articles that describe the strengths and weaknesses of these projects. For example, there's an article here, and there are more than that, and it's just, I personally think that this is completely pathetic, because the tools, they are more or less the same, but they're just different in very few parts, and I don't think there's a reason for that. Now, at this point actually would force us to work together, because we could actually have components, we could compose them together, and yeah, it would allow us to do things which we can't do right now. Now, the third goal here is what I call a so-called decentralized content hosting for semantic information. This is actually quite logical why we want this, because I'm sure you all know Git, and if you look at Git, Git is decentralized, and what was before it, they were just centralized. And as it turned out, decentralized is so much better than centralized, so obviously we also want to have decentralized tools. But seriously, if you think about it, it makes a lot of sense, because what we actually want to do is we want to abstract of the physical storage location of our information. So for example, right now we have, it's not just about tool, but it's also about all kind of other things which we need in our daily lives. For example, there are the question and answer site like Stack Overflow, there are code hosting sites like GitHub, library hosting sites like Maven Central. We have project-specific documentation, which are mostly any homepages for different libraries, their mailing list forms, social networks, all of this kind of stuff. And these are all different sources for information, but they're all different. If we first need to know about them, if you join a new programming language, it's very likely that you know nothing about these kind of things, and it takes months, maybe even years, to find all about these kind of things, and it's just a waste of enormous time. And there's just, I don't think there is a need for splitting these things up there. So in the end, what we need is not just a single interface for programs, as I showed with the first goal, but also for information. Now, this point actually works only if there's a communication layer between these different information sources, and of course there also need to be, because there is an asynchronous boundary between them. Right now, if you look at it, most of these sites, they're already in the cloud. They're just some website somewhere. We need to get information from them, and it's just the only way how to get to this information is to let them communicate through some communication layer. Now, a very famous example nowadays are cloud IDEs, and the only problem with them is I think they're completely wrong. They're not doing what we want to do. So if you look at cloud IDEs, why people are excited about them, it's you can do things which you can't do right now. For example, you could just install an IDE once, and you could reuse it from different computers, or you could just collaborate with other developers, or all these kind of things which are important to people. But in the end, what people want is not, they don't want cloud IDE, they want communication between their information and communication between components. And whenever some new cloud IDE arises, I just look at it and I think, okay, these people, they don't really seem to understand which problem they actually try to solve. What we need here is exactly that. We need a protocol that allows us to let our semantic information sources communicate with each other. It's something that we just don't have today. Okay, and one thing that's extremely important for me here is that such a protocol would allow us to be completely language independent. So we no longer would be forced to just write all our tools in Scala or in Java or in whatever programming language. We could combine them freely in any way we like. So for example, we could write some cool, the Haskell people, for example, they have some very cool type stuff analyzers, and in Scala we are more or less trying to get to the same point where they are today, and it's just, there's no need for it. They already have created it, so why should we even bother with creating it for ourselves? If they would follow a protocol, and if not just their own language, we could just reuse their stuff without caring about rewriting everything from scratch. Now the question here is where to go from here, because these, what we have here is, these are very abstract goals and they're highly indefinite, and it's really difficult to come up with an implementation just by looking at these three goals. So, but please forbear with me that I won't tell you in this talk how I came up with all of these goals and why they make sense to me. It's just, I thought about it for several months or even years nowadays, and it makes sense in my head so far, but I'm still have difficulties to put them all together and make them available in a way that everyone can understand it. So now, maybe to show you what could we do with these goals, I want to go into some examples what could we do with it, what we can't do today. And one very famous example is we could unite the editor with the browser. This is actually a very controversial goal. It's something a lot of people already work on. So for example, our browsers are already available as standalone programs. We don't have to use them as browsers, but as we can use them as any UI layer as we want. And the reason why a lot of people are doing this is because browsers nowadays are the most powerful platform for displaying information. So for example, we can not only show 2D images, but also 3D games or all cool kind of things. And obviously, I want to have this power in my IDE. So there are some people which think like, nah, I don't want this, but yeah, I mean, these people can screw themselves. I don't really care about their opinion. Now, yeah, so for example, there are some really cool features. And one feature, for example, is we could render the commit and branch history of our version control as a real graph. And even better, we could edit it. There's something that we just can't do right now with ASCII graphs. Okay. And yeah, another example, for example, is we could render the dependency relationship of classes inside of a 3D star universe or whatever we would like to have. And if you look at this, this is already what we can do in some parts today. For we already could collect the information about dependency relationship. We already could display something as a graph, but we don't really have the way to do whatever we can with command line tools, for example, today in our UI. If you use Git and you want to use everything what Git can do, you have to use the command line because UIs are just not as powerful as they should be. And the reason for this is not that the UIs are just broken. The reason for this is that the UI is not composable. If the UI would be composable, we could just formulate arbitrary commands, and it wouldn't matter if we would use them through the UI or through the graphical UI or through the command line. It just would be one and the same. There would be no difference anymore.
That's the Graphpocalypse idea as well.
Okay. Yeah, another example here is we could also edit the rendered HTML output or of any information source. So if we have Markdown, Scala Doc, or whatever, we don't really have to learn about it anymore because we can just edit everything in the browser and our tool would generate the correct stuff in the background. Now the challenge here, of course, is how do we get a reasonable performance, a small memory footprint, and all of the operation mapping correctly. And it's one of the problems most of the so-called web editors have today. They just don't get this right. And the reason why they don't get this right is not because, or the reason for this is that they don't have these main goals which are just formulated earlier. They just try to somehow do it, but it just doesn't make any sense in a more formal way. It's just they try to do it in some way, but it's not the way how they should do it. Okay, so for reference, for example, there are already a few projects like Browse Mirror or Medium Editor, and there's also an article about why content editable in the browser is terrible. And these projects, they try to do all of this stuff with showing information in the browsers correctly. So in the end, the idea of them is not very important for now, but the basic idea is that we have one single unique data structure in the background, and all of our UIs, they operate on the very same data structure. And whenever we change something in the UI, it just maps down to an operation, which is then mapped to the internal data structure and changes the internal data structure. So for example, as a graphic, it could look like this. There's this internal data structure here in the middle, and at the top, there are different ways on how we could display data. We could display the text, we could render it as Markdown, we could show it as a graph, and in all other ways. And they all access the same data, which means that if one of these tools changes any of the data would remain the same between all different UIs. It would automatically sync or there wouldn't be a sync needed at all because it's just the one and same data structure. And down here we can see that this data structure actually is not the end of what the data actually is. So if we, on the right here, once again I have shown what these nodes represent. At the top there's the presentation layer, at the bottom there's the physical layer where the data is really stored, and in the middle we have a persistence layer which abstracts over the physical layer. So in the end we could just access the data structure with different UIs, but we wouldn't have to care about how they are stored. It's just, this is a complete different problem on to store the data, and it's something which is important today, because if we want to have one single interface for example, for using an IDE or to access the information which is stored on Stack Overflow or in GitHub, we have different information sources, and we need a way to abstract over all of this, because otherwise we will also, as developers, we will always have to care about it, where the data is stored. Okay, another example which I want to go into is how to fuse documentation tools with IDE functionality. Actually, it's not just fusing documentation tools with IDE functionality, but fusing anything with IDE functionality, because overall IDEs, they're the most they're an enormous platform for semantic information, and we obviously want to have this information anywhere, not just in our IDE. So there are a few goals, for example, here, or what we could do with such a thing. We could create a central interchange platform for all sort of contributions. So if you, for example, ask a question on Stack Overflow, or if you write a blog article, these information are completely disconnected. There's no way that you just by looking at one that you find out about all of the others, and that's an enormous problem because there's no sharing between here. And if we would have such an interchange platform, which would be possible through the three main goals, we could just access all the different informations or different data sources in the very same tool. This more or less leads to the way that documentation needs to be available directly in the IDE. By myself, I don't want to just switch between browser and IDE when I want to look up for documentation. It's just not what I want. Another thing here which is important is that documentation needs to be interactive. This is what Stack Overflow got right, and which ScalaDoc, for example, got completely wrong, because the problem is when ScalaDoc is wrong, it's really wrong, because there's no way how you can fix it. You could, of course, somehow create a pull request against the repository, but the time you need to find out how to actually contribute to the project is just so enormous that most people just don't. It's just the documentation remains broken, and if you find something that's wrong, you just can't send from inside of your IDE, hey, I need to fix this somehow, and you can't share it with others. It just doesn't work. Another thing here which is important is a building quality management. It's also something Stack Overflow got mostly right. And what this mostly means is that we don't know if information remains valid over time. So for example, I worked a lot with Akka streams in the last months, and one thing I found out is that Akka streams, they change their public API every few weeks or so, which means that every blog article was deprecated after a few weeks, and it's kind of annoying. So 90% of all the information you find about Akka streams nowadays on the internet, you can completely forget it because it's already outdated and it doesn't work anymore. Yeah.
And that's why they were experimental. So I think it's just
yeah,
okay
exactly.
for Akka streams.
Yeah, it's somehow okay. Still, it's yeah. They knew about it and they marked it as experimental, but it's still annoying if you want to look at it in the first place. And there's still better ways to do this or to solve these problems. Now, another thing which is important for documentation tools is users' feedback. So if you write a library nowadays, or if you're a contributor to a tool, you just don't know if your users, they have problems with it. You have to hope that they somehow open bugs or tell you on the mailing list that something doesn't work, but you never really know what is broken. And a lot of stuff is just something which is easy to fix, but you never find out about it because users just don't know how to report it back. If you would have one central interchange platform where everyone could access this very same information through any tools we have, it would be a trivial problem because the information would be available. Okay, so now there's a few further codes, but I'm not going to get into detail about that. But I want to go into this one. So there is one thing that's kind of annoying nowadays is the BillTo integration into IDEs. For example, nowadays all modern IDEs, they have their own build tools and they're completely incompatible to every external build tool that is out there. You can just configure your project in Eclipse or in IntelliJ or in NetBeans or in whatever IDE you want, and it's just whenever it just is not what you want. What you want is you want to have one build and not multiple builds. So the problem here is that IDEs, they have to create a lot of meta files to just store their own, to just store information about their own internal build tool, and obviously this meta files they need somehow get generated. And of course, this internal information is completely incompatible to whatever is out there. So you can't just map one build tool to another, it's just not possible. This is very annoying, for example, for the Scala.js people, because in Scala.js, most people use, or I think the only way to use Scala.js right now is through SBT, and SBT generates, on the ones can generate JVM class files on the one side or JavaScript class files on the other side, and our IDEs, they just have no knowledge about this. They don't know that there are multiple output folders for just one source file. And obviously this leads to a lot of problems. So people, they just spend a lot of time configuring the SBT build, and then they start using an IDE, and then they complain about, well, my IDE is broken, because it just doesn't work, the IDE doesn't know it, and they have to invest further hours just to get to the point where they fix their IDE, where they could start working. And yeah, that's exactly the problem. So in the end, people, they don't use IDEs at all because they just don't want to spend the time to fix their IDE. So what we really need here is a build tool which doesn't depend on a programming language, but on an abstract protocol. And in the three main goals which I formulated earlier, we have such a protocol, and we could therefore develop a build tool which just depends on this single protocol. And the protocol would actually ensure that we don't have to configure different build tools for one single project. Okay, so to go into the summary here, I showed the three main goals and a few other further goals which are mostly examples of what can be done with these kind of things. And yeah, so to summarize this, what we really need as developers is we need a way to abstract over our information and to let these information sources communicate with each other, and this should work obviously among programming languages and not just among different tools. And I see this as the only way how we could escape of this cycle. So if we would be able to develop such a protocol, we could, for example, just move from one programming language to another one, and we would still be able to use most of the tools. We wouldn't just have to relearn everything. There would still be some problems because we still would have to write compilers for the tools and some semantic analysis, but in the end, a lot of stuff could be reused, which we just can't do right now. Okay, there's only one question that remains here, and it's who wants to do all the work? That's probably the that's an important question, but one that is difficult to answer. Obviously, since we are here in open source world, I took the initiative and started to create such a project, and it's on GitHub. So there isn't anything there yet, but at least I started to do something and not just sit around and complain about why everything is broken. And in case you're interested about a more formal way on how, or if you're interested in finding out more about what I thought about it, I wrote a draft document where I formulated most of the goals in a more easily accessible manner. So you could read it there. But yeah, and for anyone who is interested, yeah, we can just follow this project or follow me on Twitter, and yeah, maybe I'm able to one day to come up with something useful. And yeah, if you think that these goals, they just don't make any sense at all, and it's just not what we need something different, I'm of course would like to hear about it, because it's better to first know about it than to just find out while you work on it that it's completely broken and that you have to redo everything. Okay, and that's it. So thanks for listening.
Okay, so you were talking about the cycle, and one thing that I think is slightly missing is that there were actually attempts to gather some abstractions and to provide some useful abstractions in theory about various concepts. For example, a lot of the stuff that you were talking about, like referential transparency, location transparency, etc., was handled by a project called Corba, and we all know how it turned out. So my question is, how are you planning to avoid the pitfalls that are apparently present for those kind of projects?
Okay, so I think one of the main things here to consider is that we need to integrate the community in the first place, so which means that different people of different programming languages, they need to be aware of that, what you want to do and how you want to get there. And it's, of course, you can still make a lot of mistakes here, but I think if we would develop if we would keep the platform very small and just do the necessary things, for example, developing the protocol, and just let remain everything else to the people that actually develop tools for specific programming languages, we would achieve a good reason for people to adopt the protocol. So we could, if the protocol would be simple enough, people could just adopt it and work on top of it, and without caring too much about going into too many technical problems or something like that. So I hope this answered your question.
Okay, I have got one more. Aren't you afraid that having so unified environment won't slow down progress? It's, I don't know, like gas-fueled cars now. Everything is in place, everything is ready. You can go to gas station in another country and it all works. And now, aren't you afraid that it would prevent people from discovering new possibilities?
No, I don't think so. One thing we need to get right is that the protocol doesn't limit what people can do. So the protocol obviously needs a way to evolve on the one side, and also to allow people to add arbitrary components. So in the end, the protocol is just for communication between components. It's not about what we can do with it's just about how do we share what the information a tool can produce and which information it can take. But I don't think it would limit people in any way. The only way and how it would limit it is that it would force people to care about the protocol. But I think this is actually a good thing for everyone, because people would first have to think about how to integrate into a platform, and not how to, and it would avoid the end users to think about how do I get, or how can I integrate into the platform. It's something that the developers have to do in the first place, and would be a good advantage for them, because if you write a new programming language, you could just develop compiler, follow the protocol, and your compiler will automatically be available to a lot of different tools, and this would be a huge advantage to developers of new programming languages, because they could just find users in the first place without caring about how do I get an IDE for my programming language.
Hi, I've got one commentary rather than a question, because I fear that about one thing. Probably the majority of us knows the Xkcd Comic, and there was an awesome comic that I think that describes my fear, let us say. Wow, there are 15 competing standards, let us unify. And we're working on that. And after some time, yay, there are 16 competing standards, let's unify. So I fear it may lead to such trouble. And it is only commentary, not the question, in fact. Thanks.
Yeah, but actually I expected such a commentary, and what I have to say about this is that right now we don't even have a single competing standard, so, well, what can we do wrong by creating the first one?
Okay, so the first thing that came to mind when I saw your talk was the .NET platform. I think that's, at least in spirit, similar to what you want. You get all the tools, you get even code generators and a model to build your language and run on the .NET platform. First, I'm curious what you think about that. And second, Scala tried for many years to build a backend for the .NET platform, and it failed because still there are assumptions in that model that didn't fit with especially the variance in Scala generics that could not be encoded into that platform. So I think any kind of protocol will have some limitations that would forbid certain types of languages to run on that platform. But I would be curious first to hear what you think about the .NET platform.
Okay, yeah, first and foremost, what I really care about is making different programming languages interchangeable, so we can just connect different programming languages or different tools of different programming languages. I think the goal of adding a new backend for existing languages is kind of different, and yeah, I didn't really think so far about if such a protocol would limit how we could create a different backend for an existing language. I don't think that it really matters, because the language or what a compiler, which output a compiler produces, is not really relevant for the protocol. The protocol just cares about how can we share the information, and not where does it run. It's abstract over that. Yeah, but I didn't really think in detail about if this would result into a problem.
Are you not afraid that I'm not thinking about technical problems, but difference in communities? But are you not afraid that you won't be able to cater to all communities? I mean, I've been a long time PHP developer, and what I really love about PHP is the documentation. Actually, PHP doesn't have any official documentation. It just has a wiki, sort of wiki. I mean, everyone is used to reading the comments that, on the official documentation side, they are giving examples of usages of the functions, and there are long discussions with the users who are discussing that. So if I'm developing PHP, I would expect this sort of documentation. On the other hand, when I'm developing Scala, I'm used to using some unintelligible Javadoc automatically generated documentation listing for no purpose, like 180 functions that you can have on a list or something, which have widely ununderstandable signatures. Okay, and I'm used to it, and I'm expecting it, and I even know how to handle that. So there is a wide divergence in communities, and how are you going to approach that?
Okay, so right now the problem is that we don't really have any sharing between communities at all, so I'm not really afraid that we can't address everyone. I think it's already a big improvement if we at least are able to share some stuff between different communities, and this is of course a process which would evolve over time. So right now a lot of the way how our tools work today is because of historical reasons. It's just people did it this way because they had to do it this way, and not because it made a lot of sense to do it this way. And I think a lot of differences between communities, they can be removed by just rethinking what our tools actually allow us to do. So for example, GitHub actually is nowadays extremely popular, and it's not just popular for one programming language, it's popular among nearly all programming languages. And GitHub itself is the only thing what GitHub made great is it give the community a chance to collaborate with each other. And I think if we concentrate on just doing this right, giving people the chance to collaborate, we don't really have to fear that we leave out some communities which doing it differently in one way or another.
Okay, I think that was the last question. It's very good because we can take a 10 minutes of break, and projector decided to take a break too. So let's take a 10 minutes of break, and we'll meet on another talk. Thank you, Simon.